Okay, see Lindelof videos, AP Calculus, the Trapezoidal Rule. Um, I guess some really quick stuff. Let f be continuous on closed AB. Then we can use this trapezoidal approximation, and this is an approximation. This is not the greatest case of where you would actually use this, but this is interesting for comparative purposes. When this is usually used is when something is very hard to integrate. Then you use this approximation. But I want to show it to you this way first because I want to actually evaluate this twice. First, just take the integral, which would be 4 minus x cubed over 3, wouldn't it? As evaluated from, here, let me put my evaluation signs in here, as evaluated from 1 to 4. Oh, this would be 4x. Sorry, 4x here. And if you evaluated that, you'd get, right, using fundamental theorem of calculus, you'd get f of 4 minus f of 1. And that would give you negative 16 thirds minus 11 thirds, which would equal negative 27 thirds, which would equal negative 9. So there's our exact answer using definite integration. However, what if we couldn't use that? So we're asked to evaluate this using the trapezoidal sum. Some professors will also ask you to use Simpson's rule, but we're just going to use the trapezoidal rule today, if you don't mind. And it will look like this. First thing I'm going to do is I'm going to take a look at the rule up here. And here's the rule, and I'm just going to fit everything into that. So I am going to say my b minus a, which is my 4 minus 1 over 2 times n is 6, and they gave us that as 6. Is equal to 3 over 12, which is equal to 1/4. So that's the value that's going to go out in front. So we're going to take that. We're going to say that the estimated value of this integral is 1/4 times. We're going to take f of 0. But keep in mind before we do this that we have to really consider this change of x because we have 6 even intervals. And the change of x is going to equal to b minus a over n. Well, b minus a would be 4 minus 1 is 3, n is 6. So we're going to get 1/2 of each one, aren't we? So just to let you know what that would look like, it would look like this. We're going to start at 1, right? So we're going to get, all I'm going to do is plug this thing in. I'm going to take 4 minus 1 squared plus, all I'm doing is this. I'm just following this pattern. This 2 right here is this one. I'm going to take f of x sub next. So the next one, remember, we're going by 1/2. So I would do the same thing. I have 2 of those because that's part of the trapezoidal rule. 4 minus, we said that we're starting at 1, but our change of x is 3/6, otherwise known as 1/2. So 1 plus 1/2 is 3/2. So I have 3/2 squared plus 2 times 4 minus another half here, right? Another half here. 3/2 plus 1/2 is 4/2. So just to give you a look at it, right? Plus 2 times 4 minus 4/2 plus 1/2 is 5/2, so 5/2 squared. And all this is turns into a big arithmetic problem. Plus 2 times 4, this is my equation, 4 minus x squared, so in this case 5/2 plus 1/2 is 6/2, and I could write 3, but I just want to show you where I'm getting it. 6/2, right? Plus, I'm going to bring it down here if you don't mind, plus 2 times, the equation was 4x, 6/2 plus 1/2 is 7/2 squared. Now look, when we get to the very last one, remember, there's no 2. The first one doesn't have a 2, and the last one doesn't have a 2. And 7/2 plus 1/2 is 8/2, and 8/2 is 4. And if you look, our upper boundary is 4, so that's where we are, right? So we'll just have 4 minus 8/2 squared. Okay? So you're asking me, what am I going to do with all this crap? Here I'm going to actually use my calculator and figure out all this crap. But if you're taking the AP exam, this is what they're looking for, you to show this. And what shows up most often on the AP exam is called a partial. It's called a partial trapezoidal rule. We just have to finish it. So, oh, and I'm going to be really careful because this is an approximation, so I'm going to use my approximation sign. And if you did all this math, you'd get negative 9.1250. Of course, if it was the AP exam, you'd only go out to this many places. So here's our comparison. The actual was negative 9. By trapezoidal rule, we got negative 9.12. So there's some error there. All right. This is what's really important here. What's really important is to recognize the rule, to recognize the pattern, and then to be able to break this thing out. They are probably not going to give you a trapezoidal rule to do on the exam that could be done using fundamental theorem of calculus. It'll be something that's very hard to integrate. And in that case, your best bet would be to do an approximation. So I hope the video is helpful. If you have any questions or comments, please let me know. And if you haven't already subscribed, please do.